This lesson is proof by mathematical induction. The purpose of induction is to validate why a formula for a particular series or sequence holds. And we're going to do this arbitrarily. So there are two things we have to do. One, we have to show that it's true for the first term, or for n equals 1. And then we have to show it's true for k, that it's true for k plus 1, and then it's true throughout all of where n is a member of the natural numbers. So looking at our first proof, we have 2 plus 4 plus 6 plus 2n equals n squared plus 2n, or n squared plus n. And the first thing, everything shown in bold are the steps that you would write if you were doing it for yourself. So we're going to show true for n equals 1. So we're going to take the formula part, 2n equals n squared plus n, and we're going to plug 1 in there. 2 times 1, 1 squared plus 1. Those two statements are equivalent, so we say that it shows true for n equals 1. Now we're going to assume true for n equals k, and this is called the induction hypothesis. And what we do is we rewrite the statement, inserting k everywhere we see an n. Okay, that's called the induction hypothesis. Now this third step is where it gets just a little bit tricky. Now what we're going to do is take our step, I'm going to use a box here. We're going to take our step from the k, so we're going to start there. So 2 plus 4 plus 6 plus dot 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 2k, and then we're going to add, and now we have to show k plus 1, and on the other side, we have k squared plus k plus 2 times k plus 1. Now, notice what I did. I added the k plus 1 term to both sides. Now what we're going to do is we are going to work solely on the right side now. And what we're going to do next is we're going to simplify a little bit. So k squared plus k plus 2k plus 2. And then what we're going to do next is combine our like terms. Sometimes this strategy is effective, sometimes it's not. And then we're going to rewrite it a little bit. So we're going to rewrite. Now, if I were looking at it, I have a thought of what this needs to look like. And I'll show you that in just a second. So if I rewrite k squared plus 2k, and I borrow one of those, then I'm left with a k plus 1, and then I could rewrite this as k plus 1 squared plus k plus 1. Now, so at the end of the day, this k squared plus k from the induction hypothesis transforms into k plus 1 quantity squared plus k plus 1. And once you establish that, and then over here, sometimes I put it in a thought cloud or my target of what I wanted to have. And I wanted that right side to become k plus 1 squared plus k k plus 1. And I think if you write that little thought cloud there, then it helps you to manipulate down in these steps what it is. And then once you show that, the last statement is p sub k plus 1, and then that follows from p sub k. Therefore, it's true for all n that are natural numbers. Okay, so now let's try one all by ourselves with the steps as well. So step number 1, I'm going to use my little text box here to help keep it neat. So number 1, Roman numeral 1, show true for n equals 1. Okay, so take your formula, 4 times 1 minus 3 equals 1 times 2 times 1 minus 1, and we end up with 1 equals 1, and the first step is good. Next, Roman numeral 2, we're going to assume true for n equals k. And remember, this is called the induction hypothesis. So 1 plus 5 plus 9 plus ... plus 4k minus 3 equals k times 2k minus 1. And remember, in that step, all I did was replace all the n's with k's. Now, in step 3, now we show p sub k plus 1 follows from p sub k. All right, so start by 1 plus 5 plus 9 plus ... 4k minus 3 plus 4k plus 1 minus 3 equals k times 2k minus 1 plus 4 times k plus 1 minus 3. So there, what I did was I substituted in everything for the k plus 1. Now remember, we're going to work the right side. I'm battling with my text box here. So if I have my thought, it would look like this. I want it to look like k plus 1 on the outside, substituting that, and then I want it to look like 2 times the quantity, k plus 1, and then minus 1. That's what I want it to look like. And then really this part right here could be disguised as 2k plus 1. All right, so let's see if we can mess with this just a little bit. Okay, so now let's distribute. So 2 on the right side only, 2k squared minus k plus 4k plus 4 minus 3, cleaning it up, 2k squared plus 3k plus 1. If I factor it, I get 2k plus 1 and k plus 1. And if you look carefully at what my thought was, I do have it. If I rewrite that as k plus 1, and then I rewrite the 2k plus 1, showing it's the k plus 1 term, and then once you have that, then lastly, you start with the last statement, is p sub k plus 1, thus p sub k plus 1 follows from p sub k, and p sub n is true for all n is an element, all natural numbers. So the big thing I think for me that helps me the most is writing down that thought or target. And you'll see in all the solutions I've posted for you and all the examples that that's something that I do as well, and that helps me. So good luck. Just try your best and see what you can come up with, and feel free to ask any questions.